Now, now it's math with Mrs. P.
That would be entertaining to see every day. I wish you guys could see the outtakes because I think this is try 3 on this video, but this is test B at number 12, hopefully for the last time. Number 12 has a table that goes with it. It is an extension of number 11. I summarized part of the table right here with the key pieces of information. Ultimately, number, 12 is asking when the concentration of sodium and potassium is equivalent, and what would that dosage be when the concentrates are equivalent. So one way we could do this, I think at some point in time in the problem, it does say that these are linear, meaning that they are going to change at a constant rate. We recognize that sodium is increasing by 0.2 with each increase of dosage of 2, and potassium is increasing by 0.4 as the dosage increases by 2. I could continue to extend these rows continuing to add 0.2, so 2.2, 2.4, and 0.4, 1.5, 1.9, extending dosage as well. Notice where sodium and potassium are equal and then identify what that dosage is. But I know many of you want to know what is the math way to do that, and that math way is writing some equations. As I said, it mentions in here at some point in time that these are linear, and I think I told you at some point in time during class that even though you've learned multiple equations of a line, the only one you really need, y equals mx plus b. So I'm going to call dosage my input, and sodium's going to be my y1, potassium's going to be my y2. We are going to have to write 2 different equations. First thing we need is slope. We know slope is our rate of change, or our change in y's. I'm going to focus on sodium first, so 0.2 divided by my change in x is 2. So the slope for sodium, 0.2 divided by 2, would be 0.1. And b, our y-intercept, or starting point, is going to be 1.6. And I know that that has to be my y-intercept because we have an x value, dosage being our x, of 0. Similarly, for potassium, we are going to have a change in y's of 0.4 divided by a change in x's of 2, which is 0.2. And we have a starting value of potassium of 0.3. Now we want to know what is the dosage when these two are equal, so I'm going to go ahead and set them equal to each other and solve for x, because our ultimate goal is to know what is that dosage, which is our x. What is that dosage when these two values are equivalent? So I'm going to go ahead and subtract 0.3 to the left-hand side, giving us 1.3. And I'm going to subtract 0.1 to the right, which gives us 0.1x. Now, since this is a calculator allowed question, I know many of you are going to pull out those calculators and do 13 divided by 0.1. Just so you know, this would be something you would be expected to do without a calculator. We know we ultimately want x to have a coefficient of 1. We can swing that decimal once to the right, and we do have that 1x, which is the same as multiplying by 10. I can do the same over here, swing once to the right, or think of it as multiplying by 10, and I get a dosage of 13. Now, if I wanted to verify what that equivalent value of sodium and potassium concentrate is going to be, I could take that 13 and plug it back into each of their respective equations and figure out what that matching output is. But our ultimate goal is what is that dosage when sodium and potassium are equal, and it is going to be 13, which is option B. We'll see y'all later.